Yemen, also in Iran, which are more than 2,000 years old. They still exist and they still are used, but this is somehow exceptional. In general, I think a lifetime of about 100 years seems to be reasonable. But then we need also to design some flood release structures, some spillways for the case of emergency, and they are designed for several thousand years and based on observations which go back to the last 50, 100 years. So we assume over a pretty long time something like stationarity and similar processes in the past and in the future. How looks our environment? The brief analysis of that. Well, think about Glasgow just today. So climate change is a major issue. And we are facing the global scale increasing temperature. We are facing closely related CO2 and in general greenhouse gas increase due to our activities. But we face also, we see volcanic activities, La Palma, for instance, in these days. And we have also long-term changes due to internal terrestrial processes, which are not really fully understood. This tipping point issues, storage of greenhouse gases in the northern territories, in Siberia, for instance. And then we have also external forcings, changes due to solar irradiation. This is a short list of what we observe in climate change. What's about water management? Well, we have built numerous reservoirs. They are changing the seasonal runoff pattern. We used water abstraction for irrigation. We channelized our rivers. We have lost natural retention capacity. At a global scale, very urgent issue, losses in wetlands, increase in irrigated areas. And later on, I will give some examples related to these issues. Let's start with the climate and then we move to the water. So I was really surprised very recently, few months ago, I met a colleague who was somehow critical about greenhouse gas and impacts on climate. And this is something which exists since, well, since about 200 years. It was already explained by Fourier that the greenhouse gases and the global temperature are closely related. And this means, speaking about pre-industrial greenhouse gases, the effect of greenhouse is related to about an increase of about more than 30 centigrades. And this means that the mean global surface temperature is about 14 centigrades. Otherwise, it would be something like, without greenhouse gases, about 30 degrees lower. And due to human activities, we observe, since the last 150 years, a severe increase in greenhouse gas emissions. And this is related to glacier melting, sea level rise, change in precipitation pattern, pronounced droughts, plus many other impact areas. Here you see the change since about 1850 in temperature. And here you see the decadal averages, so means over 10 years. And it's clear that there is a substantial increase. And this is obviously and closely related to greenhouse gas emissions and increase. And this is from the IPCC report. You see here the increase in CO2 concentrations, increase in methane, and in N2O increase. In German, it's Lachgas. I don't know the nitros, I think. Yeah. So in all of them, there is obviously a severe increase. And this is man-made. What's about orbital forcing? How strong are the orbital impacts on global temperature? And I think it was it this year or last year, we had a meeting in Belgrade to celebrate, I think, 150 years anniversary of Milankovic. For those who are not familiar with that, I've included here a YouTube video that very nicely describes what the Milankovic cycles are. And these are external orbital forcings, and there are several others, but let's start with Milankovic. So first of all, the cycles of the Earth around the sun change from time to time. So sometimes they are more elliptic, as you can see here. Sometimes they are more cyclic. And this has been proven. This is, there's no need for discussion. So this is permanently changing. Also, the inclination of the axis of our globe is also changing in time. And then we have the axial precession, and this means also it's changing in time. Altogether, this means we have here the various Milankovic cycles with respect to their, for instance, eccentricity, with respect to the precision, and with respect to the obliquity. Obliquity means changes here in the inclination of the axis. And in parallel, you see the changes in CO2. This has nothing to do with human intervention. This is due to it's closely related to the Milankovic cycles. And we see here a period of about 800,000 years. But have a look on the level of the CO2 variability. So between 200 and 280. Yeah, much lower than concentrations we are facing today. But conclusion, there is a high confidence that orbital forcing is the primary external driver for glacial cycles. So it's driving substantially our climate, but it's also related to changes of CO2 due to freezing of large parts of our globe and then melting. So this is always related also to emissions and decrease of CO2. This is taken from IPCC, so it's not something strange. It's scientifically on a sound basis. And present-day concentrations of greenhouse gases exceed the range of concentrations recorded in the ice cores during the last 800,000 years. So we are substantially above what we have seen in the past. And there is high confidence that these changes in atmospheric CO2 play also a relevant role in glacial interglacial cycles. And when we see the changes in the Milankovic cycles are somehow small with respect to the total sun irradiation, but The driving force for changing our climate is the reduction in the northern hemisphere insolation. And this generates sufficient cooling to initiate ice sheet growth. Models have proven that, and this is also something which is approved. What are the cycles? The dominating factor is obliquity, 41 kilo years, so pretty long period. Orbital eccentricity, well, 400 kilo years. So it's really very long. Axial precision, it's a little bit shorter, 25,000 years. Apsidial precision, more than 100 kilo years. So in general, very long cycles. What's about volcanic activity? You see here two figures. They have the same time scale. So we see in the upper graph about the last 1,000 years, and in the lower figure about the last 1,500 years. And these are major volcanic events which have changed the aerosol injection into our atmosphere. And you see here, due to volcanic forcing, the decrease in energy input. So also quite relevant, but this refers to rather shorter periods of a few years. So mostly we observe these impacts, SO2, ashes, CO2 emissions, etc., over periods of, well, periods of years. And at the global scale, it's measurable what the impacts are. So decrease in that range due to aerosol emissions. Additionally, we have other cycles, and I've listed here a few. So very well known, the sunspot numbers, and these are cycles due to solar activity. So this means internal solar processes, development of a dipole, changes of the dipole, etc. This is reflected by different cycles, can be monitored, and sunspot numbers have a rather short cycle. So you see here, in general, we are already at a much shorter time scale, and the consequences are measurable. Also, the well-known Hallstatt cycles, they can be also appointed to Milankovitch theory because they are related to the revolution of Jupiter, Saturn, Uranus, and Neptune around the sun. And this has a cycle of about 2,300 years, and the Hallstatt cycles observed in sediments, in boreholes, etc., are of about 2,200. Also, the Gleisberg cycle, they are very closely related to sunspot numbers. But these figures, these cycles, are found in different regions of our globe. So they have also an impact on our Earth system. Sunspot numbers have been analyzed with respect to hydrological impacts already in the past. So I refer to the important work by Rodriguez, Iturbe, and Jevčević in the 1960s. And they said no significant correlation between hydrological time series and sunspot numbers. Very recently, there was a study. They found a correlation between the hydrology in the Amazon River and sunspot numbers. Later on, it was denied by another study. So in general, I would say it cannot be proven that there is a visible relationship between sunspot numbers and hydrological processes, but with respect to our climate, there are some links. And now we have studied orbital impacts, human impacts, volcanic impacts, and here you see a comparison of these impacts on, for instance, temperature anomalies. Be aware that the scales here are different. So, for instance, the anthropogenic component is related time scale refers from 1880 to about today, and you see there is an increase of about more than 0.8 centigrades at the global scale. The solar component, due to sunspot numbers, which you can clearly here see the cycle, so there is an impact, but much below 0.05 centigrades, the amplitude, much below. Volcanic components are larger, but short lifetime and then a decay within a few years. And when we and these are the internal variabilities in temperature due to, well, you could say random processes which we first of all don't understand, and due to ocean cycles and atmospheric cycles. So comparable in the range to about the volcanic component. And when we add up these components, we see here observed changes in black and the sum of these four components indicated by red. So overall, I would say the fitting is good. And now let's have a look in more detail on human interventions on the water cycle and on the climate. So directly, we change the greenhouse gases, and this has some impacts on precipitation and temperature. We change the vegetation cover. This has some impacts on the water. On the water cycle. We change, due to water management, the storage capacity of our globe. We build the reservoirs. We initiate to the land use erosion, and we exploit our groundwater systems. So we have one cycle from the atmosphere down to the groundwater system, but due to temperature, due to air humidity, we have some vertical processes reflected, for instance, by evapotranspiration, and this has also impacts on the various layers. And due to our activities, we change all of them. So therefore, when we analyze, for instance, surface hydrology, some processes, we should consider what has happened in the last 50, 100 years with the land surface, what has happened in the same period with the composition of the atmosphere. So as I've listed previously, we abstract water for irrigation. We change the regional runoff pattern. We accelerate river flows due to generalization. We have impacts on extremes. I will come to these points later. We overexploit the groundwater table. And then, this is a separate issue, there are failures in management of our water resources systems. Few words about some of the topics. Water abstraction. About 85 to of global fresh water is used in agriculture. About 70% can be allocated to irrigation. There is no clear inventory about the dams which exist. In general, we could say there are millions. Total storage capacity, a rough estimate, refers to about more than 8,000 cubic kilometers. And we see also that due to water abstractions, mainly used for irrigation, well, we changed the surface water systems, large lakes disappear. And if you're interested in, but it would take too long, there is a nice study about regional trends in the water balance in some of our, at the continental scale. A figure about the discharge of Colorado River at the southern border. The black bars refer to measured discharge over a period from, well, 1910 to about 2000. And this is the time series calculated on the basis of water abstractions in the upper catchment of the undepleted river. So this would be the pattern of Colorado River without any abstraction. So you see major differences, and for longer periods, even the river dries out. Well, that's one example. But now it does not work. How can we proceed? Sorry, it seems to be blocked.
Try harder. Sometimes it is a little bit, or just hit it with mouse click.
Yes, but it does not work. Sorry.
Is it video?
No, 1 second. PowerPoint is blocked due to something.
Okay, yeah, it went on. Yeah. So, sorry guys, like Peter would need to reload his PowerPoint.
I will restart again. Let's see where we are. One second. So we are here. And now and you can see it?
Yes.
Hello? Yeah,
yes.
Good. So I hope it's working now. Due to water abstraction, for instance, Lake Aral disappeared. They have diverted the rivers Amudarya, Sirdarya in the upper part, and the discharge into the former Lake Aral more or less came to zero, and this is what you see today. So only some small parts of the former Aral Sea remained. It has nothing to do with climate change. It's direct human intervention into the water cycle and due to extended irrigation issues. We did a study some 15 years ago about possible measures to rehabilitate at least some smaller parts. Some smaller parts can be probably restored, but it's not only a question of quantity, it's also related to quality. We'll not go into detail. It's not only Lake Aral. You find similar pattern in Lake Chad. You observe shrinking of the Dead Sea, and Lake Urmia in Iran exhibits similar characteristics. So all these large water bodies are shrinking or have already disappeared, not primarily due to climate, mainly due to human activities into the water cycle. We have also changed the seasonal runoff pattern. As an example of Austria, we built a lot of high mountain reservoirs to store the meltwater, to utilize the water for hydropower, especially in wintertime. And here you see the results. So you see this is decrease in summertime, and this is an increase in wintertime for one river in the Alps. So the seasonal pattern here in this river basin is still visible, but we have modified it. What's about human impacts on extremes? Our colleague Zbigniew Kunczewicz from Poznan, Poland, he estimated flood damages, he analyzed flood damages, and his conclusion was annual damages are about $19 billion a year, and about more than 100 million people are affected by flood events each year at the global scale. So we have invested a lot in flood protection in most of our catchments, but we observe an increase, tremendous increase in damages. So some people say, well, that's climate change. But IPCC report states there is low confidence at the global scale regarding even the sign of changes in flood frequency. So it means it might go up in some regions, in other regions it's going down, but there is no coherent picture. This is an increase in flood damages. I've taken this, I think it's from Munich Re. Yeah, both are from Munich Re. This figure here shows the total estimated damages, and the darker bar here indicates the insured losses. So you see the estimated damages go up, but also the insured losses go up. So this might become a problem of reinsurance companies, or there is already a problem for reinsurance companies. Again, when you analyze historic patterns, and this is an example from Vltava River in Czech Republic, you see here a time series of about 1,000 years. Here recording started, and this analysis for the last from 1100 to about 1850, they estimated flood peaks on the basis of reported damages and reports in various archives, so historic archives. The black bars indicate large events, and the gray bars indicate extraordinary floods. The difference is indicated here. So extraordinary floods are between 2000 and up to 2,900. Catastrophic floods are above 2,900. And what you see here is the number of events within a period of about 20 years. And have a look on the black bars. There is no indication that catastrophic events are increasing. And this is found at several gauging stations. So when you analyze that, there is no general trend. Obviously, and this can be proven, local flood events will become more frequent and intensive. But independently from the flood frequency, the damages have substantially increased. And why? Mostly due to changes in land use and to improper land development plans. In other words, people are living in areas where it is risky. And this is somehow known, but still we proceed in this direction. So what are the consequences for our thinking about mid to long-term changes in our environment? In general, Milankovitch cycles are by far too long to be considered in, let's say, our daily decisions with respect to management and design. But we can also learn something. The Milankovitch cycles have shaped our basins, and due to sediment transport and sediment deposition, they have shaped our groundwater systems. So there is valuable knowledge included in the cycles in relation to the structure of our alluvial deposits. They drive the climate in the long term. And what we see today in our data sets, I mean also in our long-term analysis, so ice boreholes and sediment layers, etc., that today and over the last period, human activities are the main drivers at the recent scale. And still, well, few slides about failures. Maybe we could learn something from our failures, and a few examples. So this is an example from India, Fatehpur Sikri. It was designed as the capital of the Mughal Empire about 450 years ago, and quickly after building the city, the city had to be abandoned because of water shortage. So maybe it is related to regional climate change. Maybe it's related to improper design. So it's a wonderful museum. You can go there about 80 kilometers south of Agra city, and really huge city without any inhabitants. Irrigation schemes. It happens permanently that irrigation schemes have to be abandoned because of salinization. It's at a global scale an urgent issue. So we disregarded our irrigation technique, we disregarded the structure of the soil, the components in the soil, and this led to salinization over large areas. We built, as I've shown previously, a lot of dams and levees, but everything what we build can fail. And it's not that we can blame the engineers. Well, engineers don't know how to build a levee or a dam. It happens in each region of the world, and it happens especially under severe conditions. For instance, here, this is a levee in Austria. In the back, you cannot really see it, but there is the emergency team, and the levee even has not been overtopped, but it collapsed. And here, a dam collapsed somewhere else in the world. What are the reasons for these failures? Well, we have a weak database, means short time series, corrupted by measurement errors, etc. Usually we have a short planning horizon, and this is not in harmony with the various changes we observe in our environment. When you think about irrigation, maybe we have improper specified objectives. This may also hold for land development plans. There is no consensus among stakeholders. For instance, when you think about Lake Aral, upstream and downstream countries, they don't have a coherent framework for collaboration. So therefore, all these problems emerged. About dam failures, etc., very often it's related to insufficient maintenance of structures, and there are also construction failures, of course, but it's also related to disregard of the dynamic changes in our environment. And as I've tried to show, we have cycles of different scales. Some of the cycles are in the range of time horizons for planning. We have shocks coming from volcanoes, coming from extreme flood events, etc. And when we analyze the main impacts, then we see, well, there is obviously a clear trend in many, many time series. Losses in fertile land, increasing pollution, increasing pressure on natural environment, increasing greenhouse gases, as we have discussed. And still, even today, there is continuation of the Glasgow meeting. Still, we disregard our limits at the global scale and at the regional scale. And all what refers to human interventions with respect to the composition of the atmosphere, so I'm speaking about the period since 1850, goes beyond what we have observed over the last 800,000 years. And this is due to human greenhouse gas emissions. Still, you have seen the range. Milankovitch cycles are also reflected and are linked with CO2 changes. There are a lot of internal feedback mechanisms, deep and Atlantic conveyor belt, North Atlantic fluctuations, El Nino, etc. They generate also additional cycles. You can prove that by frequency analysis. Should be considered in some regions of our globe, okay? And our perspective in design and in management is very often very, very short, so something like 100 years, although we design something for several thousand years. For instance, flood protection in the city of Vienna refers to something like a protection level of a flood, which has a return period of something like 10,000 years. I think it doesn't have too much meaning. What means 10,000 years? You have seen the various cycles, so we are already in the range of glaciation and deglaciation periods. And I would summarize that the direct human interventions, especially in the water cycle, are substantially larger than the impacts so far from climate on the water cycle. But this is not an excuse to disregard climate impacts because it's an additional impact. But today, human interventions on the water cycle seem to be more severe than the climate change impacts. And I didn't say something about ecosystem services, etc., but they are essential for our survival, and preservation of ecosystems is something which deserves more and more consideration in our management and planning. So I tried to give an overview of orbital impacts, cosmic impacts, human impacts, and I hope it was useful for you. Thank you. Hello?
Hello. So thank you a lot, Peter, for your the most insightful talk. Also, additional thanks for managing this exactly within the allocated time frame. Like it feels like your professor was very high standing and very long experience. So thank you again. So dear colleagues, please your questions. We have plenty of time for this time. You can, if you feel shy, just type them. If you feel brave, just unmute yourself and shoot. So the first question, where do you think the land use planning is integrating the ecosystem services in the best possible way? I think the question is like where geographically it's happening.
Good point. Good question. We have several documents referring to integrated water resources management. And in these documents, you find very useful recommendations. Implementation is another issue. And the same with climate change. You find very nice proposals, etc., about preserving our forest systems and reducing CO2 emissions. But when we start with implementing these recommendations, then problems are faced. I would say I'm in Europe, so I know more about Europe than about other continents. But I would say, for instance, some directives related to water, framework directive on water, flood risk directive, they are a good starting point, and they are an example of step-by-step implementation. Why? Because they have well-defined objectives, and each country in the European Union has to document the progress they have achieved. And every 6 years, these reports at the national level are compared and jointly evaluated, and deficits are indicated. So I think this is an example that something can be done and it's working. And for instance, when you think about the flood risk directive, it has two objectives. The first objective is reduce existing risk. And the second objective is avoid the emergence of new risks. So this means consider what has happened in the past and avoid the emergence of new risk. This is clearly related to land management, land use development. And this is perhaps a useful example.
Yeah, thank you. Just a little question slash comment from myself. To continue the question of Dr. Swati from India. Considering that Europe can be considered as a good example of coherent set of legislation and regulation, and also there are monitoring and following up mechanisms. Still, I would imagine that even in Europe, there are some implementation deficits in relation to this legislation. Could you probably mention, to your knowledge, what they're happening, like what kind of settings, geographical or political, are more prone to this kind of implementation failures, and actually are those failures, and how common they are?
You ask me.
Yes, I'm asking you. I'm just curious.
Well, from a perspective of a water manager, I would say there are, at the global scale, some examples of transboundary river basin management which are considered as useful. And definitely all the existing agreements or frameworks for transboundary water management can be also criticized. So I think when we speak about Lake Aral, for instance, there has been, when this irrigation system has been developed in the 1960s, 70s, etc., there has been an institution which was responsible for the whole basin. Due to the collapse of the Soviet Union, all these national states like Tajikistan, Uzbekistan, Kyrgyzstan, Kazakhstan, what have I forgotten? Turkmenistan, they have developed their own strategies, and really it worsened the problem. Even before, it was not, the region was not in a good state, but today I would say it's much worse than it was before 1990s. No coherent database is available. No joint agreements are really implemented. Some of them have been signed, but they are not implemented. I've been some years ago I've been invited by the Zambezi River Authority in Southern Africa. And they have also, SADC, I think it's called, an institution which is responsible for water management issues in the Zambezi River. And I think, of course, it could be improved. Everything can be improved, but something is working there. This means countries are exchanging their management plans, countries are exchanging data. So this is something. In the Nile Basin, there is the NBI, Nile Basin Initiative, which has been mainly launched by the World Bank. I think a good initiative. I was at the beginning involved in some of these activities. Still, a lot needs to be done. So the collaboration between upstream and downstream countries is really lacking. So you find some Mekong River Authority. Again, my task is not to blame someone, but making river authority, I think they have achieved something with respect to developing a coherent view on the whole river basin. But still, in the upstream section, reservoirs are built which may have severe impacts on the downstream countries. It can be improved, and the collaboration between riparian states needs improvement. But still, there is an authority which supports the communication. And this, I think the initial step is to develop trust among the various partners. And the second step is to establish a joint database, and then you need to agree on objectives. So even if everything is lacking behind, still, I think some achievements have been reached. Coming back to the framework directive on water, what I like also is that they emphasize in this directive also non-structural measures. So the flood risk directive on water, non-structural measures are emphasized. And this means not, when you speak about flood risk management, not to develop more levees, not to develop more flood retention reservoirs, to think about non-structural measures to provide, the Dutch people say, give room to the river. And this is, I think, an objective which takes place. It needs pretty long time. So think about Milankovitch cycle. So timescales are different. So our expectations are very often disappointed with respect to implementation. In some areas, it's really a critical issue when I think about climate, but also in water, I think we need to do more. I hope it's a useful answer.
Yeah, thank you. It's a very extensive answer indeed. So then we have a question from Pravin Kumar, again from India. How to plan for the long term when there are high climate-related uncertainties? What kind of time frame one should keep in mind for planning projects?
Good point. I would slightly rephrase the question. When we think about time frame, usually we apply simulations, but the simulations are very often based on, as I tried to show, on time series from the past, and then we modify and we generate new time series, etc. Maybe we think about a scenario approach, that we say what would happen if, and we assume scenarios even without assigning a probability to them. So only to look what would happen if, for instance, flood frequency increases by 10%. I don't know what it means with respect to a time horizon or so. But when you look on the climate change data, for instance, then you get every 5 years, you get new climate scenarios also, and the range among them is quite huge, because we don't know how which emissions scenario will be finally implemented, or which will take place. So instead of, or additionally to a probabilistically based analysis, we should also think about various scenarios. What would happen if people move to a certain region? What would happen if rainfall would change? And this might be a first step. And in the second step, we learn something about the vulnerability of the system we are analyzing. And this leads to the question, what kind of strategies could be used to reduce, in general, the vulnerability of a system? I mentioned very briefly, for instance, ecosystem services. Or another example, when you provide more space to the river, you increase the natural retention capacity, whatever the development of floods will be in the future.
Yeah, thank you a lot. Any other questions? No questions
Yeah.
in chat?
Yeah, I
Dr.
have a
Swati, please
question.
go ahead.
Yes. Thank you, sir, for a very interesting lecture. So I have a question related to what you've just mentioned. I want to know if there are countries or if there are organizations, associations that are sharing this information of the river basin or the vulnerability risk or you know at a local level. So my question is coming from the fact that so I'm coming from India. So if I have to buy a property, and if I don't know whether it actually falls into a flood risk zone, and I buy the property and something happens, maybe 10 years, 15 years down the line. So that system here, we have everything in place, but it's not transparent. So are there any countries that are actually, they have platforms or they have shared the entire spectrum for the next 10 years or projections, something like that?
Well, it's an obligation within the European Flood Risk Directive that each country, member state of the European Union, elaborates inundation maps for different probabilities of occurrence, plus elaborates maps which show the exposure of objects, plus maps which indicate the flood risk for people and for objects. These maps are available and public at the EU level. And due to our dynamic environment, these maps have to be updated every 6 years. Also, I like it, but I would like to add a few sentences to the case of involvement of the public. In all these directives, it's required that the public is involved in even in developing plans, in assessing the proposed measures to reduce the risk, etc. But I think involvement of the public is, or requires also the education of the public. Means people have to be informed from the early beginning, and they need trained to understand what has been elaborated. And also they need to be trained to understand that the problems are. Maybe it's a very critical statement. When we think about democracy, I think it's not sufficient to throw a piece of paper every 4 or 5 years into a box. This is a good starting point, but this is not a solution. In between, people need to understand what's going on, and people need to be educated. This has a lot of implications, but we enter a completely different domain. But I would say we would need time to learn about our systems, about our social system, about our environmental system, and about our global system. And then hopefully we would develop pressure to implement all these nice strategies and proposals which were elaborated at the scientific level and at the community level, etc.
Yeah, thank you a lot. And with this question, indeed, you also touched a very important and huge issue, which is well outside the scope of this lecture, that now we're living in a new information universe, when people from public, and not only from public, but also from epistemic communities, they receive overwhelming amount of information. And then you have a lot of difficulties with this, like a lot of trade-offs and like what information to pick up, which one is relevant, which is not. You easily overlook important pieces. You easily is overwhelmed by pieces which are probably less informative but somehow hype-based. And I remember from one of your previous sessions, you talked about the new communication system for floods in Austria, and that many people started to use this system in order to go there and to make selfies, and that's how several persons actually died, exactly because they didn't run away, but because they ran in to make the selfie. So it's a strange universe we are entering now, but yeah, this very well beyond the scope of this talk.
A short comment to that. We receive a lot of information. I fully agree with you. A lot of this information is probably not useful, and due to the case that people are uneducated, they don't realize that when they go to take a selfie during a severe flood or something, that they take a risk they don't know about. So they are uneducated. And information requires at the same time also education to understand what is being provided and what has been elaborated.
Yeah, that's true. We have space for one very short question, if anyone has one. Yeah, I think we had a very nice elaborated discussion. Also, your session was so crystal clear that probably no questions raised. I would ask you, Peter, to send your slides if you're fine with this, and any literature you find useful to support your statements. I'll post them on the e-learning system, which is password protected, not available from outside. So thank you a lot for your most insightful talk. It was very enlightening. I heard many sessions by you on similar issues, but every time still gives me new food for thought. So thank you again. Thank you everyone for attending. At 11:30, we'll have Professor Rob Youngman from Wageningen talking about North Sea and ecological connectivity issues in this important sea basin. If you're welcome to stay and participate also in this session. Speaking about intense webinars, on the next week, we're gonna move away quite significantly from the topic of today, and our colleague from the Ho Chi Minh City University for Natural Resources will talk about kaolin absorbents in water treatment. Interesting issue in itself, and I'm looking forward to it a lot. In our November seminar series, we're also going to have a talk by Dr. David Stanners, who was like for many years a senior person at European Environment Agency. He will be talking about sustainability transition and how it entered the discourse, and what are the foundations and political implications for this. And at the end of the month, we'll also hear Dr. Saxema from Honolulu East-West Center in the United States, who will be talking about peri-urbanization. And on the 1st of December, as the last session of our November series, we'll hear Professor Kucher from Kharkiv, Ukraine, from Kharkiv National University, and he will be talking about soil management and related climate change issues, and how climate change mitigation and adaptation relate to soil management. I think it's a very interesting and diverse program, and you are most welcome to follow it. Thank you, Peter, again for your time and for your most insightful talk, and I hope to see you alive the sooner the better. So you're welcome to stay or to leave. As I mentioned, at 11:30 European Italian time, we're gonna have a talk by Professor Rob Youngman. So see you soon.
Thank you all. Thank you very much. Thank you for your polite words, Anton. Thank you.